Today we are going to talk about ProxylessNAS. This was developed by three PhD doctors who studied in Massachusetts Institute of Technology. Today I'll be the one who will be presenting this paper. By the way, myself, Jayamarthi Kumar, I'm a master student in University of Texas at Arlington. So this is the overview of our presentation. First of all, we'll be looking to the abstract, then we'll be looking into the introduction, then we'll be diving into the methodology and its experiment and its results, and finally we'll be looking at the conclusion. Okay, abstract. First of all, AI. We know every AI is rapidly growing in our daily life, but we'll be looking into a specific neural network called as NAS. What does NAS means? NAS is neural architecture search, has great impact on designing effective neural network architecture. However, it is not efficient to use on a large scale. This is because it has a high GPUR. To overcome this, we started utilizing something called as differential NAS, but it also suffers with a high GPU memory. To reduce the high GPU memory, we started utilizing something called as proxy. Yet the proxy tasks are not guaranteed to be optimal. To overcome these, we introduce something called as ProxylessNAS in this paper, which we'll be discussing detailedly going through. First of all, what does ProxylessNAS architecture mean? As from the name, you can realize that ProxylessNAS means an NAS architecture without a proxy. To generate a ProxylessNAS, firstly, we will construct a over-parameterized networks known as DAG, that is Direct Acyclic Graph. Okay, it is recording. Then we provide a new path level pruning perspective for NAS, that is we'll be looking into a single path at a specific interval of a time, which is also called as binarized architecture. Then we propose a novel gradient approach for handling hardware objectives. The name of the algorithm is gradient based algorithm. Then finally we'll handle non-differentiable objectives like latency. Here in the below link you can see that it is a link in GitHub. This is where the old development code exists. You can look into it for your full clarity. Anyways, we'll be looking into the methodology. In the upcoming presentations, I will be discussing about the methodology we utilize in ProxylessNAS, but we won't be looking into each and every specific line of code because it is practically impossible to do so. Whereas I'll be showing you where the code exists for each and every attribute we have introduced in ProxylessNAS. Okay, firstly we describe the construction of an over-parameterized networks with all candidate path, that is creating of DAG, which is abbreviated as directed acyclic graph. So this part of the code exists in cipher module.php. I have highlighted the location where the Python code exists, that is, it is called as cipher module. Then it comprises of n candidate primitive operations such as convolution layer, depth convolution layer, pooling, zero layer, etc. These code exist in layers.py. You can see in detail. Okay, then we set each node to be a mixed operation that has n parallel path. This set of code exists in mix underscore op python code with the class name of mixed edge. Now the DAG exists. Now we start to reduce the memory usage by introducing the idea of path known as binarization. As I stated before, here we will be considering only a single path at a specific interval of time. This will reduce the memory footprint. We keep only one path when training the tail. It's abbreviated as I stated before. So by using the binary gates, we achieve only one path of an active at runtime. That is, at one specific time, utilizing the binary gates, we will be utilizing only one path. So we update the architecture parameters and weight parameters alternatively. So these are the codes where we used for doing the binarization. Latency is not something you can differentiate. like before we look into gradient, which is a differentiable function of accuracy, latency is not a differentiable function. So for doing so, we'll be introducing a two algorithm that is making latency differentiable, as well as something called as reinforcement based approach. So in this diagram, you can see how we make the latency into a differentiable function, and the code as such we utilized. And we introduced the reinforcement based approach to train the binarialized waste as well. And it is also possible to combine both gradient based approach and reinforcement approach to form a new updated rule for the architecture parameter. So we utilize the existing data set, that is, we'll be looking into Cipher10 and ImageNet, and which will be uploaded into our ProxylessNAS. So by doing this, we will be representing ourselves that our module is far superior than the existing models. Okay, so Cipher10. So we replace all the three x3 convolution layers in the residual box to a tree structure cells of a pyramid net. In the small snippet, you can see that a pyramid tree net has been introduced. These are the small snippet of the codes where you can see. Sorry for that, it's a mistake. Anyways, these are snippets where we have updated the existing model, and we'll be introducing the Cipher10 to show that our model is far superior than the existing models. And ImageNet. For the ImageNet experiment, we focus on learning effective CNN architecture. We utilize three hardware platforms, that is GPU, mobile phones, and CPU, which you can see in the right hand side snippet, where we show that we are utilizing CPU, GPU, and mobile. So in the table here, it represents that our Proxyless GPU is as the least latency, which states that our model is completely superior than any other existing model. And also layers.py consists of the RESTnet, MobileNet, and all the other modules, which is utilized to compare our Proxyless NAS. So finally, we'll be looking to the conclusion. So from the graph, you can see that our Proxyless NAS is far superior at any moment of the time. And also you can see that our RMSE is 0.75 milliseconds, which has the least amount of latency. So by introducing the ProxylessNAS that can directly learn neural network architecture on the target task and target hardware without any proxy, we finally reduce the search cost, that is GPU-R and GPU memory. So hence utilizing ProxylessNAS has given an optimal solution.